Except for Ted, he's got it right as earlier. All right. For the major quiz, which is the entire unit, this is what you need to know. How to add and subtract matrices. Again, in order to add or subtract matrices, the only way that's possible if the order is the same. Can you multiply a matrix by a number out in front? Super easy. Each item gets multiplied by that number. So the adding and subtracting almost seems that it shouldn't be, it should be maybe taught in grade 7 because it's that easy. But then we get to multiplying compatible matrices. That's when things are complicated, that the columns of the first matrix, yes, and the rows of the second have to be the same. In other words, this would be possible. A 3 by 2 multiplied by a 2 by 7. This would be possible since the middle numbers are the same. And the resulting answer matrix would be what size? A 3 by 7. So first of all, the middle numbers have to be the same in order for it to be possible. And once it's possible, the outside numbers tell you how big the answer is. And as Michael just demonstrated, that's where we took the row, turned it on its side, crashed it into a column, picked up and added up all the pieces. Okay. Can you square a matrix? Well, you could only multiply or square a matrix if it was a square matrix, because the rows and the columns have to. Okay. The transpose, where we switch the rows and columns, the zero matrix, the identity matrix, a singular matrix where the determinant is equal to 0, and finding the inverse of a matrix. 2 by 2s without your calculator, so that's where you find the determinant, do 1 over the determinant, one set of diagonals get switched, the other set of diagonals get multiplied by a negative. Well, you will by Tuesday. Okay. Yeah, they did. This is new. Find the inverse of a 2 by 2 matrix by hand and the inverse of any square matrix using your graphing calculator. If you need to borrow a calculator on that day, you can. Solve using the matrix method. That's using the inverse. So maybe we'll put the matrix method is when we use the inverse, and using the Gaussian and Gauss-Jordan methods to solve systems of equations. Okay. So the first two, if we were solving using the matrix method, that's where we set up a matrix for our coefficients. We make sure that our coefficients or our variables are written in the same order. We make our variables matrix and our answers matrix. And we say let matrix A equal this one, let matrix X equal this one, and let matrix B equal this one. So basically what you have is AX equals B. We want to solve for the variables, so we have to get rid of the A on the left-hand side. And unlike mathematics you've done in the past, you can't just divide by A. Dividing doesn't exist in matrices. But you can multiply by the inverse. If I multiply this side by the inverse, I have to multiply the other side by the inverse as well. And the important thing is the order. So if I multiply by the inverse in front on the left-hand side, I have to multiply by the inverse in front on the right-hand side. A inverse times A will be an identity matrix. An identity matrix will always multiply by something else and make it equal to itself. So in essence, this side just becomes x. And now we can write this out if we had to do this by hand. Our A inverse, if we did our determinant, this would be 15 and 9. 15 minus 9 is 6. So we would have 1/6. Our inverse matrix, this diagonal gets switched. This diagonal gets multiplied by a negative. And then we still have matrix B, -5, 9. I would leave the 1/6 out, multiply first. So this answer will be a 2 by 1. Row 1 times column 1, -15 plus 27 will give us 12. Row 2, -15 plus 45. So you know that x is equal to 2 and y is equal to 5. You could write your answer that way. You could leave it as the big X equals 2, 5. That's fine. If you want to write it as a coordinate point, that would be fine. Yes? The 1/6 comes from the determinant. And the determinant is calculated by multiplying that diagonal together and subtracting this diagonal. So 5 times 3 is 15. -3 times -3 is 9. 15 minus 9 is 6. And that's called the determinant of a 2 by 2 matrix. Now, the determinant tells you whether an inverse exists. If the determinant is 0, the inverse can't exist because you're not allowed to divide by 0. If we do a quick check, 2 and 5, does it work? 10 minus 15, -5. Second one, -6 plus 15, 9. So the nice thing, or the not nice thing, right, about these questions is when you get your answer, you can plug them back into your equation to find out if you did it right, which is nice when it works and will cause you all sorts of frustration when you're like, oh, it didn't work. I made a small mathematical error somewhere. For our second one, is it all right if I erase the first one? Everybody was good? Our coefficients matrix, 3, -4, 2, -1, 1, -3, 4, -2, 1, x, y, z equals -3, -6, +4. Again, I will make this, let a equal this, let x equal this, and let b equal that. So we have ax equals b. And multiply in front by A inverse. And this one, if you're doing the matrix method, this one would be a calculator question. So what we're going to do is we're going to go to our calculator and enter that matrix in A and that matrix in B. Did I click on it? I think I did. Come on, calculator. Yeah. You rewrite the first two columns. Don't do the formula, though. The diagonals are so much better, isn't it? I'll show you. It's easy. I'll show you after. Meanwhile, the calculator is warming up. I had it on. Okay, so now it finally loaded up. That only took a long time. I am on. Here we go. So 3 over -4 over 2 over. I'm going to try something different with this one. Over 1 over -3 over 4 over -2 and 1. Look at this, all in one step, storing as matrix A. Syntax, no, it didn't syntax error. There it is. So that is, okay, one thing I highly recommend is when you type it into your calculator, you do a quick check that all the numbers are the same. One number different will cause all sorts of problems. And matrix B, -3, -6, and 4. There we go. So if we wanted to find A inverse and write out A inverse on our calculator, we can go second matrix, A, hit the inverse button. There's A inverse. If you have A inverse as decimals and you want to change it to fraction, you hit your math button. Number 1 is changing things to fractions, and it'll change all your numbers to fractions. That is a good question, Michael. And I am going to expect that. Okay, so there's our inverse matrix. Now, you wouldn't have to find this and write it down, because to find x, what do we need to do? We need to take A inverse and multiply it by B, and we get our answer 2.2, 3.64, and 2.48. Interesting. It's interesting because it's not nice numbers. I kind of expected it to be nice numbers. But I guess if it's calculator, question, it really wouldn't matter if they're nice numbers or not, but it kind of is annoying to plug those back into the original equation. Did everybody get those numbers? Nobody? You got fractions. No, this one by hand would not be very nice because of those numbers, right? Okay. So, this is the matrix method, where you set up your matrices, your coefficient matrix, your variable matrix, your constant matrix, and then you multiply by the inverse in order to solve. Gaussian elimination. Gaussian elimination, what do you need? Just 1 0. You just need zeros underneath the diagonal. You don't need more than 1 0. Gauss-Jordan elimination is when you need all the zeros and ones. I shouldn't have shown you the calculator. Yes. All right. Even better. But we'll go through the technique to practice it anyways. So I need to make this one right here into a 0. So I need to change my row 2. How could I make that into a 0? Well, I could take 5 row 2's and add 3 row 1's. Because that would make 1 negative 15 and 1 positive 15. So if I did that, well, row 1 doesn't change. Row 2, though, this will be a 0. 5 row 2's, that'll make this 15 minus 9. This will be a 6. And 45 minus 15 will give me a 30. This is all you need to do for Gaussian elimination. For Gaussian elimination, once you've got this far, you can now say 6y equals 30, y equals 5. And 5x minus 3y, which is 5, equals negative 5. So 5x equals 10, and x is equal to 2. Yeah, we'll see how it works. Let's see. We'll at least get the zeros in the bottom corner. So we'll need 3 zeros for Gaussian elimination. We have 3, negative 4, 2, negative 3, negative 1, 1, negative 3, negative 6, and 4, negative 2, 1, and 4. Good luck in your game. Here we go. So I need this to be a 0 and this to be a 0. So starting with row 2, I can make row 2 a 0 if I took row 1 and added 3 row 2's. I could make this a 0 if I took row 3 plus 4 row 2s. Row 1 stayed the same. Row 2 is now row 1 plus 3 row 2s. That gives me a 0 here. Negative 4 plus 3, negative 1. 2 minus 9, negative 7. And negative 3 minus 18, negative 21. Row 3 plus 4 row 2s. That'll give me a 0. And row 3 plus 4, that'll give me a 2. And row 3 plus negative 12, that'll give me a negative 11. And row 3, 4 minus 24, negative 20. Now, the other day when I was going around with checking on people, this one is the next 0 that you need to make. Whether you're doing the Gaussian Jordan or whether you're doing the Gaussian. And this sometimes causes problems. I'm just going to add a little note. That if you want that to be a 0, you're going to have to use row 2 and row 3. Because if you introduce row 1, because there's a number in the first column of row 1, you'll get rid of one of the zeros you already had. So now in my next step, I want to change row 3. I have to use row 3 and row 2. It'll be row 3 plus 2 row 2s. Three, negative 4, 2, and negative 3. 0, negative 1, negative 7, and negative 21. And row 3, 0 plus 0, that'll still be 0. This will now be 0. Negative 11 plus negative 14, negative 25. And negative 20 minus 42, negative 62. Really nice numbers. But at this point, we can now say that negative 25 times z is equal to negative 62. And z is going to equal to 62 divided by 25. Hey, that's actually some good mental math. That's what? Is that 2.48? Is that what it was on the other page? Yep. Yes. Wow. Just wait. Wasn't done. It was half of an 8. Half of an 8. 2.48. And that matches up with the answer we got with our calculator. So what would you do next? You would go to this second equation in Gaussian elimination. And you would say, I know that negative y plus negative 7 times 2.48 equals negative 21. Yeah, I wouldn't either, so we're going to cheat. Just, follow Michael's footsteps here. 3.64. This is what his recommendation. And then you could go to your first equation and say, well, 3x minus 4, and we know that y was 3.64, plus 2, and we know that z was 2.48. That has to equal negative 3, ... And you would find out that x was, what was it, 2.2? Perfect. So in Gaussian elimination, you always need zeros underneath the main diagonal. And you don't have to go further than that. Then you sort of go back to your algebra, do substitutions all the way back to find your answers. the name of the one to make zeros on the top one is Gaussian Jordan, right? So the Gaussian, just one set of zeros. Gaussian Jordan, this is the one where you need ones along here. All of these ones are zeros. Yes. Yeah. Are these the same questions? Oh, I don't want to do I don't want to do that one. No. Do you want to do that one? No. Because it's not nice numbers. Because matrices suck. All right. Let's turn. Should I give you one that works out nicely just to see if you can get the 3 by 3? Yeah. Let's do a nice one. I am going to. Oh, no, I'm going to make one up. So chances of it working are really, really slim. They all equal 705x plus 3008y minus 45z equals 0. No, we won't go. But we will start with, I'll be nice. I'll be nice and make the first one a 1. But I would say if you ever have a 1 in front of the x, wherever that equation is, you should write that one first. So if I have x minus y, let's see, what should I do as my numbers? Oh, yes, perfect. Plus z equals 4. They're all 2s. 2x plus y minus 3z and 4x minus 5y plus z let's go here. 12, 15, 42. -3. There you go. The video. Okay, there. There's the answer if you're doing it at home. If you got any fractions, you did it wrong. And next, these questions are non-calculator. So you have to practice your matrix multiplication. All right, I think most people have multiplied these out by hand. And when you multiply them out, for the first one, you got ones along the diagonal and all zeros, which means the A inverse is equal to matrix B. Because whenever you get the identity matrix as an answer, that's what happens when you multiply something by its inverse. And then in B, when you multiplied A and B together, you got all zeros. Wow. And 6s along the diagonal, which means A inverse would have to be 1/6 of B. Because if you multiplied by another 1/6, then you would get all 1s. So that's why this was a non-calculator question.